Oh, why do we have to? Okay. So last time, after banging our head against the brick wall for so long, we finally rendered an image of Pluto, I mean 134340 Pluto, to the screen using WASM. And so clearly, like, really, like anyone, if they're like following any like HTML like tutorial, can like learn how to just like get an image on a web page within like 10 minutes. And so this currently doesn't illustrate that WebGL is being used in the background at any stage. And so before I upload this before I add like an example to the actual to these examples online, I want to play with the shader a bit. I want to get this like animating, get this moving in some time. I'm also kind of concerned that it took a while to get these GIFs to load. How large are they? We may need to shrink these from 7 megs of GIFs is a bit too much. Okay, we need to think about shrinking those a bit later. But in either case, I want to, just like all of these, clearly WebGL, a shader is being used for these. I want to illustrate that a shader is being used for this sometimes. So I think one thing I've never done but seen in any like image editor is something to do with grayscale. And so I think it could be interesting to just think about how to actually maybe like mathematically what's involved. It won't be that sophisticated, but I think it still may be interesting. And then perhaps like implement a shader so that this image of Pluto sort of oscillates between a grayscale image and a and like the color version here. So I think maybe a start to any of this is to instead start with a shader that oh no, this might it's always asking me. This always seems to like tank. This always seems to tank the bit right here. I just keep this open just to see if this is. Oh, let's see. It seems to be fine. It's not tanking. Yeah. So currently, this thing is animating. It would be, I think, good to sort of use this as a base to figure out how to get the grayscale working to some extent. We might change, say, like the white that's in the background here to a different color in the spectrum. So maybe we make this less red, so maybe like 0.2. Maybe more blue. It's at least something with some extra kind of something just slightly different so that we can actually test out the grayscale. Where's the width of this? Oh, the radius is itself something we can adjust. Yeah, but then I think once we like work out how to get the grayscale working on this, we will then be able to add it to the shader and get stuff going. Okay, so before I like read up on how this works on the internet, I kind of want to just like try and figure out some of it myself. So let's say, so I guess in order to make this grayscale, we're going to have to transform what's basically this three-dimensional space of red, green, and blue values into something that's one-dimensional. Something that has the same value from the same red, green, and blue value. So like a lot of information is going to be lost. A naive thing to do would be to like average all three values. Let me try this. Okay, so let's say we have the final color is this thing, but then I'm going to zoom in. Where's view settings? So we'll have usual color here, and then if we make the final color equal to basically a combination of these. So if it's a grayscale density, grayscale, let's call it a grayscale value. So let's actually try averaging these things divided by usual color dot is going to allow usual color dot, let's just call this usual. Usual dot x plus usual dot y plus usual dot z. And then for the final color here, we just want to make let's just also call this gray value. Or just gray. Gray v, gv, we'll call it gv. gv.x, well, it's just gv, gv, 1. Okay. Okay, so that's kind of somewhat working. We then have the question of what would this actually look like with some kind of image data. Almost certainly CodeLife will have some way of processing texture stuff, but I kind of don't want to figure that out today. Okay, just averaging kind of work. Well, something more sophisticated we could do. So I suppose a problem here is that, say like we decided to make this like background, this background color, which is currently here white, something that's like, if this, right, like if the sum of these three values is the same as the sum of these three, it will be indistinguishable. So we could easily say sort of red is equal to 1, 0, 0, 1, and then blue is equal to 0, 0, 1, 1, And then if we decide to change the background from this Kumasama red to that, and then we change this from blue, it's gone, since we're not distinguishing them at all. So I think it would be better to think of like, some way of turning this into grayscale that we still could like doing this wouldn't make the colors disappear in some way. Like it wouldn't work for every image, but maybe for like a large enough set of images. For instance, something like, something like the image of Pluto. It's alright. Zig image viewer, dwarf planet. Like, yeah, maybe. Okay, so what? So I kind of see there's like three things that need to be done. The first is modifying what we have here so that we actually get an oscillation between the current grayscale and the color. The other thing is then thinking of a more sophisticated grayscale way. It kind of is optional, we could actually drop that. And then finally transferring that to the Zig code in order to apply it to this image of the dwarf planet here. Why don't we just get something at least animating to begin with? Okay, so now say we have this like three-dimensional, this cube of like side width, you can normalize it, like this unit cube where each axis is representing red, green, and blue, and we want to compress all of that down. Okay, we're using a linear, like a very simple linear transformation in order to do that at the moment. So if we somehow wanted to turn this into like a continuous family of operations, what could we do? I feel like I'm gonna have to do some sketching. Let's just save this as like we can bring this up at any stage. So we'll keep this in like the background, so we know what the aim is. Is GIMP okay. Yeah, I'm sure this can be updated, it's fine. Anything can do, we're just sketching. Okay, yeah, so we have this unit cube of colors where we have like, say like the green and the blue values, then we're literally turning that into like a line. At the grayscale. So the current way we're doing that by just averaging everything is just by a simple, like just a matrix. Like, okay, technically, if we're considering this as being like a line within the cube, maybe it's more helpful to think of it that way than what we really want is just, let's choose like some color. What we really just want is like that diagonal line. And so let's see, currently the way we had it when we were just summing everything and averaging it, we're just making like a diagonal matrix where we're there's no space. I select the eraser tool. I can select this and delete it. Currently, right, it's just the, oh, come on. Clearly I use this tool a lot. It's just the diagonal matrix where it's just summing all of these. So we want to like somehow turn this into a family of continuous functions that, a family of continuous linear transformations that will go between the identity matrix and this thing. There's a nicer way to represent this. If we just call it half x plus y plus z. Okay, so maybe just literally writing it out will make it easier to come upon inspiration. And all of this is like, there's like a 1/3 everywhere. Okay, so so what could we do? One thing would be to parameterize these, like since each of these components already has like already has some like some stuff. Let's just do like a new canvas, discard changes. So yeah, we want to like, we're basically just doing a given a vector, we're literally just like putting ones everywhere. So we could make, is there like a pointer thing? We could basically make a bunch of these ones like parameters that go between 0 and 1. So in particular, let's make one of these like orange or something. Yeah, like we could, like it wouldn't simply be enough to say like make a, oh come on, didn't I not? It wouldn't just be enough to make a bunch of these go between 0 and 1, because we'd then have to also make these ones go between a 1 and 3 in order to like normalize everything. But we probably can just adjust this as well so that it like automatically normalizes the matrix. But there's probably some really simple way of doing this that looks alright and is really easy to think about and therefore implement in code. So we could try something like just making all of these zeros just represented by some constant lambda, and then what? And then okay, say we just let 0 range from 0 to lambda range from 0 to 1. We would then want to divide everything by 1 divided by 1 plus lambda, 1 plus 2 lambda. And then this way, like the sum of everything should, by definition, stuff will be normalized. Okay, so we can try this. Yeah, so we want to just create a function that given a lambda will make a matrix. The lambda here takes values between 0 and 1. And then the matrix here is just going to be 1 divided by 2 lambda plus 1. Then 1 lambda, lambda, lambda 1, lambda, lambda, lambda 1. And then, yeah, when lambda is equal to 0, we get the identity matrix. When lambda is equal to 1, we get the grayscale matrix, and then it should just smoothly interpolate between them. And look, maybe there'll be visually something more effective to do, but we can just get rid of this. How do I collapse this pane so it disappears a tab? Yeah. So we'll just implement this. It will take less than 5 minutes, if even that. Okay. Can I get rid of this sidebar at all? Oh, I can. Good. Okay. Okay. So back to opening this then. So yeah, so we wanted to say, okay, we're going to have to create a separate, may as well make this a separate function. What is the, okay, surely the type is mat 3 by 3. So we want to have mat, and we could just say what should we even call this function? Lambda, L to mat, let's call it L to mat. And this will take a float, and then it will return the 3 by 3 matrix. Function does not return a value, L to mat. Yeah, so here we just want to return mat 3 by 3. Presumably we can just list these values. Okay, so 1 plus let's just say the normalized value, which is 1 divided by 1 plus, let's keep everything floats, 1 plus 2 times the lambda then yeah, now we want to return the norm times, was it 1? Okay, I don't want to write lambda bajillion times, we'll just call it L. 1 L L L 1 L L L 1. Okay, to me this looks fine, but apparently it's not. Lambda undeclared identifier, yeah, 'cause it's L. We'll do something really silly. We'll just say constant L is equal to float L is equal to lambda. Surely this will get optimized out. Okay, so we've got that. So then let's include that. So we've got our usual color here, and then we want to say, let's create like a vec3, which is like lambda color. So this will then be, let's just specify what the matrix is. Mat 3 by 3. The L mat, the lambda matrix is going to be L2 mat, whatever the lambda value is. Let's just like set this to be 0.5 to begin with. Well, we can do better. Let's just make it a uniform. Let's add in another parameter. Lambda. Oh, it's not going to, let's call it double L. So double L can go from 0 to 1. Okay. Constant, no, we want uniform. A uniform float, double L. Okay, and then set this to be the double L. Okay. Now we have the matrix, we can say vec3 L color is equal to the L mat times the usual dot XYZ. Will the shader allow me to use that language? Good. Then get rid of this color. What we want over here is now just the L color and then bar 1. Okay, so now it's good. Like the background looks kind of gray, and then if we, right, we can like, we now interpolate between like the full color and then the grayscale and the grayscale. This doesn't look too bad. At least to my eyes. Like I feel like we did like one of the simplest ways of transforming it. Like I don't know otherwise how we could make this, like it's not going to always be the case that like the first thing that came to my mind was the simplest, but to me this is like, this is clearly very simple and a simple way of doing it, and I don't otherwise know how like other ways to make it really simple. Okay, so that's good. So now let's just get this into let's hook this up to a to something that can be oscillated with. We already have a time uniform, so we may as well use that. So for the L value, let's say lambda is equal to, let's say it's basically like the sine value of time. So we take sine of time and put that in here. Okay, sweet. Going between the stuff. Do we want to adjust the time of this? I think this feels fine to me in terms of an oscillation time. Okay, so let's now let's port this over to WebGL and see what weird inconsistencies lie in store. Yeah, why don't we just get this working, and then once this is animating in, once this is animating in the shader in the browser, then we can do our post-exam homework or review or whatever, and actually see how grayscale stuff is done on Wikipedia and other places. But hey, we got it working. We figured it out from scratch without looking at any references. So well, we figured out our way of doing it. So goal achieved. Just gotta change it. Okay, so we want to do. Let's open up our example. Once Windows decides to open it. Okay. So we're going to have to pass in a uniform into here. But before any of that, we can just repeat what we did over here. Simulate a uniform with like a constant. Simulate everything with a constant. So, so let's say we have a constant. We can just call that the LL. Constant float LL, and let's set this to be 0.5, and then we're going to set this lambda. Okay, then we want to create this extremely simple function. If we can even do this in WebGL, I guess we'll see. So yeah, mat33 lambda to matrix float. Let me just call it weird that with it indented like that, and then yeah, we'll say float norm is equal to 1. We can just copy this. Okay, and then yeah, and then we just want to apply this to the stuff in here. So let's compute this first. lmat is equal to lambda to matrix lambda. And then we'll say like to do make that uniform. Yes, we've got the matrix, and then we've got the texture color. So then we want to say the L color. Oh, again, we can just copy this, right? So I'm gonna have to adjust it anyway. L color is L matte times texture color dot XYZ, and then the frag color is going to be the L color one. Okay, so let's give this a go. We should get something that's somewhat gray. A Zig build dwarf planet. Oh my goodness, why is like never say this. Why is like PowerShell dropping frames? Is this, we're not dropping frames on stream, okay. So yeah, that compiled, of course, so, but will it compile in OpenGL? Different question entirely. Python, let's launch it again. Okay, it's clearly not gray. Okay. Shader fail. No precision specified for float. It's this nonsense again. Okay, but yeah, line 10, line 12. So I guess we have to say like constant low p float, and does that mean I need to say low p float up here? Maybe let's give this a go. Okay, those errors have gone away, but now I'm at 3.3 syntax error. Okay, oh, we could, right, we figured out last time that code life, we can use like the ES2 syntax, and so maybe maybe we can do something similar here instead. So let's copy. Okay, let's copy this function first and see and get this compiling. Okay. Syntax error expected identifier. Yeah, is this not a type? Let's just search this. WebGL. This error message is extremely unhelpful. Like, what are we meant to do? Maybe here we can check out the ES specification, even though this is like the most recent one. Yeah, so like this mat like 3x3, it's still like here. Maybe we just want mat 3 instead. What even is the difference between these? mat3x3 versus mat3 OpenGL. It's basically OpenGL. Okay, so it's just it looks like it's simply an alias. Okay, that in either case we'll just use that. Okay, so say we do go to OpenGL to can I really not say mat3 like lambda to matrix float L and then simply say like return mat3 100010001. Okay, I guess that's okay. So I suppose the trick here was not using that 3x3. Like that's literally all it was. Okay. Never mind. Let's try compiling. Yeah, I guess that's it. Try compiling this again. We're failing to specify the precision for floats again. Line 12. Do we really have to say this is, okay, I guess if we need to say it's like a low p vector 2, it would make sense for this to be a low p mat3. But is it going to whinge that like every single one of these is, sure, okay, surely it can infer from this that that's different. Maybe we just need to like sprinkle low p's everywhere. And now it's line 13. Dude, we have to like put bloody low p everywhere. This is so stupid. Let's just put it in every single place ever. Low p. I guess this should be low p as well. Are you happy now, shader? I've added it everywhere. Wrong operate types. No operation star exists that. Okay, I guess we forgot to add in version 100 when we tested this in CodeLife. Let's go back to here. So version 100, and then hopefully now we'll get a lot of, also why is this using IP? I'm using low p. This is like the worst part of any programming. Like we figured it out, figured out the mathematics, we got the stuff working in OpenGL, and now like just transferring it, even though it's like exactly the same. It's like, nah, this like it's almost like you submit some like short story to an edit and they're like, oh, the house style is using like single quotation marks instead of like double quotation marks. And you're just like, that's your only feedback. Like that's basically useless feedback. Like it's like, come on, it's like not doing anything. Okay, so maybe saying like precision low p float means we can drop the low p from everywhere. I hope so. It's ridiculous. Okay, it seems to be compiling. Right, if we make this like, okay. So maybe this is the trick. We just declare precision low p float at the very top. And then get rid of here. Not again. Okay, now it looks like it's actually a it's like, this is like an okay error to have. So now it's saying what? Yeah, it's saying I'm confused about converting an int to a float. Oh, so it must be the 2 here instead of 2.0. Okay, gonna really be annoyed if it's like, I don't understand, this is like the integer one instead of the float one. We'll see. Okay, that is fine. And now 21 is complaining about this. Right. Constant mat3. Wow. Mat3 lmat is equal to this. That was a legitimate error. Aha. Oh, cool. Okay. And yeah, now it's like slightly gray. So, okay, the horror of transitioning the shader from OpenGL to WebGL is over, probably. So if we make lambda 1, for example, now, and recompile, this should be like full grayscale. Oh, it's not. Okay. This is, it's really, I suppose there's a design choice here, which is that now this is really confused. Why is this? We changed it from a 1 to a 1.0. Shouldn't it be working? Okay, good. Now it's all grayscale. Like I can see that there's a design decision in the shader, which is like every integer will be represented by, which is like, if in the shader there's a bunch of ASCII characters, like numeral characters, if there's no decimal point, interpret it as an integer, otherwise interpret it as a float. That's fine. That's like it's an easy design decision. But then like at least be like Zig and have like that's one way of doing it, but then another way is like the Zig way, which is way better, which is just like anyway. I would like to have like the fact that this is specified as a float here should be enough. It should be enough to go, okay, the shader compiler will interpret this thing as being a float. Like I can see if it's just like lambda equals that, then you like, in the absence of that, you then use this rule, but like, it's otherwise a bit nonsense. Anyway, let's save this. Started making dwarf planet grayscale. Get that to the internet. Okay, so now we want to add in a uniform that is going to allow us to, to change the value of this lambda. So I think we can just replace the const here with uniform. And then what we're gonna have to go into the main code and adjust accordingly. So the stuff is still commented, great. So say we have got the time in seconds. Let's just say lambda is equal to the same thing, 0.5 lambda, which is an F32. 0.5 times 1 plus the sign of time seconds F32. See, the Zig compiler knows what that is. And then we want to get the lambda uniform location of lambda. How many? Okay, we're not dropping any frames yet. Good. You get the uniform location in the texture shader program, and then you want to update the value. Let's just replace everything. It's time here with lambda. Except it's lambda seconds. We want that to just be lambda. Okay, and then yeah, I think that should be enough. So let's check it out. Zig build dwarf planet. Okay, pointless discard of local constant 306. Yeah, didn't know that was a Zig issue. Okay, let's actually launch the web server again. Oh, okay, doesn't like it. Uniform cannot initialize this type of qualifier. The pain continues. Okay. If it says it can't initialize it, we won't set it to 1. Aha. And aha, we can see it changing between grayscale and color. Yay. This isn't just a like 5-minute like syntax. Like I get annoyed when people say HTML is programming. It's just a markup language. Is writing markdown programming? No. Constructing like an interpolating family of matrices? Yeah, that's actually programming. So let us Currently though, the rate at which the color is changing is a bit subtle. Like if anyone looks at this for like a second, they may not actually, and that's all. Like they might go, oh, like nothing's changing. So we'll increase the lambda value. So let's now change, we want to increase the frequency, so by how much? We could double it. Yeah, I think it will look at least a bit better when it's doubled. Let's see this again. So here, like an issue is that it's like not red enough for most of it. It's like red for a tiny bit and then it like becomes super grayscale. Okay, maybe this is the point at which we want to adjust the family of what we're doing. So right, so say we want to adjust this so that more of the lambda values are closer to 0 than they are to 1. Currently everything is just symmetric since we're using the sine function. We could do something like an inverted normal distribution. That would like kind of pulse it. There could be some better ways. Like it hardly stays red at all before it just changes. Another thing we could do is actually not go full grayscale. I feel like it's cheating in some way. We could also try something that's not continuous. I mean, at least like not smooth, as in like literally not differentiable an infinite number of times. Not infinitely differentiable. The instance, we could do something with like a parabola. What are some ways? Like it should at least be C1 or C2 differentiable. Maybe we'll open up the GIMP again. No, git bash. Also, I think the image itself is like is it like 480 by 480? Oh, wow. I can't even check a preview image of it in File Explorer, but bit sad that FilePilot doesn't show QRI files. But we can still check out the, we can't check out the details of it. We can, let's just see what the, Emacs, what are you doing? What's the size of the file again? So what was it like? The width is 0, 1E0. 0, 1E0. Okay, so it is 480 by 480. So let's change the canvas width to 480 by 480. The image, the photo. We may as well. 134340. There it is. By 480. May as well at least get that working. This way it should be slightly more crisp. Okay. So yeah, so let's no, we just want to do something to draw on. I'm not doing the Princeton colors. Okay. Okay. Yeah, so currently what? We're just, the lambda value is, we're oscillating it between 0 and 1. But we want it to be more, does GIMP have like just a widget, like some like thing that like comes out that you can just select the color and otherwise everything's alright? That's kind of what I want. Let's say we do, this green looks pretty. Oh, it needs to be darker. There should be some shortcut for like going between these. Oh, X. Okay. Great. Okay, we can do a better color choice. Okay, that's easy to see the difference. Okay, yeah, so I think we kind of want it to be more above the blue line. Like maybe we want it to be like, oh, come on, I keep on pressing. Can we do like a new layer? Just delete everything. I just want to clear the canvas. Okay. Okay, finally. Okay. So yeah, so to remember which, okay, so we're currently on black, so yeah, so currently it's like typical sine wave stuff, and then we want to like turn it into this. So yeah, what could we do? We could pass the we could somehow like apply like a stretching factor to this interval, and so say like say we have the unit interval here. We could do something where this is like highly non-differentiable, but we could do something where like we map like everything going to like 0.8 to like 0.5. So like everything in here becomes like this stuff. Okay. Okay. What are some other options? Okay, we could do something where instead of like, say this is again like the unit interval cross the unit interval, instead of having just like a straight line here, we kind of like curve it like this in some way, and then let's see, this would then which direction do we want to do this stuff in? Yeah. So if we want more of the stuff that's located at this end to be higher, then we want to be like bumping up values here to be something higher. So okay, we do want something that's like, why this has changed. I was perfectly happy with the color I had before. We want something more to be like this. Okay, then this way it will still be smooth enough. Okay, I think we'll end up doing this. So now we just need a function that takes that takes like x to y, but is gonna perform this bump. So what could that be? Where we send x to, we could just make this like half of an upside down parabola, if like that's the parabola. It's like crude, but easy to work out mathematically, almost trivial to implement in code. So we'll do that. So let's figure out what equations that is then. So okay, so we want to have let's try again. So we have 0 and 1 here, and we just want a parabola. Okay, a parabola where like the vertex of the parabola is up here. So what's this going to be? We don't need to use y equals. We are we know what functions are. We can just say the function here is going to be what, x minus 1 squared negative, and then add 1 to it to offset it. Great. Super trivial to implement. So let's get that in. Let's get this in code live first before we jump back into the horror of converting it to stuff in WebGL. Yeah, so it's just negative x minus 1 squared plus 1. We can remember that. So okay, so let's do like a what's happening in this thing? This is super complicated. Let's say GL frag color is equal to final color, and we'll just make this back for final color. Can we swap? Okay, this already is in GSL2. I'll call this fancy. And here we'll have final color is equal to fancy. Okay, so we want to like implement this stuff. So in this case here, we'd want to put the time through something. So we could say let's call this like double T time. Float T times equal to time. And then this T time is what we're going to want to put through this like parabola. So so let's say float oscillating value is equal to 0.5 times 1.0 plus, it's so silly, sine of time. And then now we want to put this oscillating value through the parabola. So now we say, call it p-value is equal to, okay, we'll make the p-value equal to the oscillating. Okay, so now it's like oscillating back and forth. So here we want to have, well, yeah, it's just negative, will the shader understand negative brackets? We'll see. Oscillating value minus 1 squared times oscillating minus 1 plus 1. Okay, so yeah, so now it's in. This is going to be a bit subtle to try and notice the difference between in this case. Let's just make the final color grayscale, and we can just see how it's pulsing differently. T time 1. Okay. Let's also speed up the oscillation. Okay, so currently it's like this, and then if we now change it to just equal the oscillating value. of that version, and then yeah, like in this version, it's it like feels like stuff like doesn't stay around for as long, but in this version, stuff is really subtle. Yeah, this one, it's like, once we put it through this, it's like staying at like, it feels like it's like staying closed and like opening quicker. Okay. All right, so we'll come back to this drawing board if, let's save this somewhere. Okay, we'll call this like oscillation experiments. Okay. So we'll come back to that, but otherwise we're just adding in very simple formula. So, so in the fragment shader, we don't even need, like, we shouldn't be doing this in the fragment shader. Let's just do it in Zig. We have way more control over things. So here we want to say, instead of just using a sort of a trig function for the oscillation, put it through the parabola f of x is equal to negative x minus 1 squared plus 1. So then we can say oscillating value is equal to this, and then lambda is equal to negative oscillating value minus 1 times oscillating value minus 1. I guess we can even factor some of this out. Wait, there's a very, very simple algebraic way of writing this. Alright, we'll just we'll leave it like this for now. Yeah, okay, so now let's see how this will make a difference to this. And then, okay. Okay, so yeah, so like the flashes. oh, hang on, if 0 is the identity, oops, we're not done yet. If 0 is the identity and we want to be spending more time on it, then we're going to want something, oops, we're actually going to want it to go like the other way. We could easily change the function. Yeah, let's just, okay, the function is now, okay, this is, sometimes it's like this. So if 0 is what we want the value to be more of, then, right, so that is the direction we had in our shader. Yeah, when L is 0, it's just, yeah. Then we just want the parabola that that passes through the origin and is equal to 1 at value 1. In other words, the parabola is just x squared. And so lambda is now just os times os, and that's it. Okay, way simpler, but it was really simple to begin with. Okay, great. Now when we see this is oscillating, it appears colorful for way more than it was before. Is this changing enough, fast enough? We might even speed it up. Let's change the speed. Pulsing speed. Okay, we can actually be precise here through okay, like clearly the period for the sine function is 2 pi, and so say we have like period in seconds. Let's say we make the period 1, then whatever time value we have here, we then want to divide by 2 pi, 0.5 times seconds divided by pi, and then multiply this by the period. We want to divide this by the period, right? No, we're being silly. If it's the period, we multiply the time seconds by that and then divide it by 2 pi. Okay. This is like, let's compile. Use of undeclared identifier pi. Oh, really? Well, we need it now. Standard.math.pi. Okay. Get that rendering. And now let's see. Oh, now it's like it's changing super. Is it changing at all? Okay, why is this suddenly changing so slowly? The period is not 1 second. Let's just think about this abstractly and then figure it out what it should be there and then rewrite it. So usually every like 6.8 seconds, if we only ever had time seconds in here, it would take 2 pi seconds in order to do stuff. Oh, okay. It's because we're like, it's like order of operation stuff. I think. No, okay. We're gonna think about this later. I don't want to think about this now. Let's just make something called speed, and the speed will be 3, and we'll simply pass in time, seconds, f32, speed times this. No one cares if the pulsing is like precisely 3 seconds or whatever. If people want to do that, they can do it themselves. I just want to get this animating. Yeah, is this speed alright? We could even change it to 4. Yeah, I think this is what we go with eventually. Yeah. Sweet. So I can say get add dot, get add dot made colors pulse faster and with more color. Okay. So now this is done. Let's do the GIF stuff now. So let's get this on GitHub, but change it so that change some of these GIFs so that they weren't several megs, but just like 300 kilobytes instead. So we can lead with this. We should probably also clean up the code a bit beforehand. Let's clean up the code. So yeah, activate the texture, bind it, at the location. So we called this uSampler. Let's change the name of it. Oh, it's in the fragment shader. let's just replace U texture, U texture with like Pluto texture. U sampler. Always the wrong pane. Oops. We just do it by hand. Pluto texture. U sampler. Pluto texture. Or rather, it's not just making it active. Make the GPU use the Pluto texture. And then draw the dwarf planet. Okay. Into the photo. Actually, this is kind of obvious from this. Set the lambda uniform. Yeah, which like we can say yeah, which adjusts how gray the image is. Oh, there's also stuff with like the pixel stuff. We can probably, it'd be good to like tidy this up a bit as well. Okay, let's just compile and test what the changes we just made. You never know. Clear everything. No, it's still working. Good. No need for that to be open anymore. Yeah, so let's deal with this stuff. Oh, maybe we should save what we already have. Not needed just yet. So there's no reason for us to assign space on the data segment of the WASM for this, since we're just using it temporarily. So I think we can in fact just create this on the stack. Granted, this is a large amount of space to be creating on the stack, but I think well, I mean, I think I saw like Andrew programmed a lot of the WASM stuff, so if if it doesn't work, it means that we're doing something really we are not using the stack in a correct way, but I have high confidence that this will work. So like this is like philosophically, not on a technical level. Like, no, you shouldn't be allocating like a gigabyte of space on the stack. You should be using an allocator for that. But I feel like the kind of like meg or however large this uncompressed image is, which is like, what even is it? Yeah, basically a meg. I think it's fine. I think it's okay to have like a meg of space on the stack. I don't foresee any issue with that. Okay, so yeah, first of all, unpack everything to there, and then do it to the actual pixel bytes. Okay, let's test this out. Okay. Well, let's try again. Okay, apparently, yeah, we're really, we are exceeding what is allowed, probably. Yeah. Index out of bounds. Yeah, to me this basically says that yeah, in the WASM, like the stack is not allowed to exceed some certain size, and we busted that here. So yeah, I guess we'll go back to allocating into the WASM. Maybe later on, yeah, maybe like before, like later on when the Zig JavaScript bridge is converted to Zig 14, maybe then we'll like clean up the stuff. But for now, it's like, it's fine. This is fine. I don't want to have to like dig into the QI file again just to get this working. It's okay. We can manage. It's fine the way it is. Okay. So what else then? Okay, so there is another experiment we can do, which is to bitcast the pixel bytes as to basically make a, yeah, to like do like a, oh, we want to do like a pointer cast actually instead. So in case things have actually been packed together. So let's say we now comment out the Pluto pixel bytes. Let's say we comment all of that stuff out. Down here when we call this, we could actually try pointer casting this. Zig might complain that it doesn't know what we're trying to pointer cast it to. Yeah, well, also because that doesn't exist. Pluto pixels. Okay, finally, here's the, oh, we've hit a to-do. Implement coordinate pointer cast between slices, changing the length. All right. It is good to know, like, it's always good to know you're on like the cutting edge of like a language when yeah, when you do actually get stuff that's like it's coming down in the future. Okay, we tried. We should add this in, like note as of Zig 0.13.0. What was the error? Upon trying to pointer cast an array vec for U8 to an array of like U8, if this is even sensible to begin with, we get a error. So yeah, let's see. Still compiling, good. But yep, otherwise this looks good to me for the moment. Okay. So let's just do one final clearing the cache, checking this is all right. Let's do a de-optimize release build. Let's just clear everything. Clear remove .rz cache. Let's remove the Zig out as well. Zig build dwarf. Let's Zig build dwarf planet de-optimize equals release fast. Get this working. So in Zig out, there's only the dwarf planet. And when we launch Python, yep, we get stuff. Get stuff working. So so now let's capture a. Oh, we installed ffmpeg last time or sometime, right? ffmpeg. Good. Okay. So now we'll be able to convert our examples to GIFs that are not huge, are not like 3 megabytes and other stuff. But actually, before we do any of that, let's update the README to have this example we've just added. The README is going to have a link to the GIF anyway, so okay, we can actually do the GIFs. We'll do the GIFs. So yeah, so the size of these, 2 of these, are not okay. Where where was this stuff saved when we made the recordings? Was it in videos, screen recordings? Looks like it. There's so many fractal GIFs. Fractal.mp4. Yeah, so, and rainbow triangle.mp4. So yeah, let's convert both of these with FFmpeg, since that's what any website online is doing anyway, whether they say it or not. So FFmpeg convert GIF, MP4 to GIF. So how are we going frame-wise? Are we dropping a lot of frames? No, still keeping them strong. Maybe it's just this like apartment building, and during the nighttime everyone's like streaming, so the rate goes down. It's fine for the moment. Yeah, let's just like viewed more than 500,000 times. Okay, this looks like the way to go. Okay, this looks fine. Bunch of values, but this is kind of what we want. Let's make a new folder called like WASM GIFs, or WASM GIF converts. Let's just duplicate stuff in case we somehow override it. Okay, and then what about the blinking? The blinking screen is fine. Well, maybe we can compress it even more. Maybe we'll see. We may as well. May as well see how well FFmpeg compresses that. Okay, now we want to make our own recording of Pluto. Or I should say 134340 Pluto. Let's just do this on like a black background since screen record is weird. Is it clipping tool? No. This here. That's probably longer than it needs to be. Let's okay. This should be better. Yeah. Okay, so that should just automatically be saved in somewhere in here. Where are we? Oh, here it is, yeah. See, the first one, 1 meg too big, but this is okay. For 134340 Pluto. Okay, now I can start doing FFmpeg conversions. to, so yeah, copy this. Then, we want to go to what, videos, screen recordings. I can't allow myself to work in something that has a space between the names. Let's just move this up to videos. Why did it copy two things? I didn't ask for that. Okay. Okay, warning, I'm about to wait, what does PowerShell say? Okay, you're about to paste text that contains multiple lines. It may result in the unexpected execution of commands. Let's just copy it to... oh, we can get rid of a lot of these. These lines are in here just to like wrap. Okay. So what do we want to change? So input. Let's start off with 134340 pluto, and then output this as like pluto.gif. And what are the options? This example will skip the first 30 seconds. No, we don't want that. T is like 3-second output. Presumably, we can get rid of that entire flag and it will just do the whole thing. FPS 10, I think FPS 10 always looks kind of crappy. What are the size of these things we want to do? Scale filter will resize the output to 320 wide. I guess we can try. This would be the easiest way to change the size of it, presumably. So we can just try it. Try 300, and then okay. Let's give this a go. Done. That was so fast. We're like never using the internet to convert GIFs again. That was yeah, never again. Okay. However, this is now like this is too big. What are some flags? What are some ways of reducing the quality? What even is this question? Oh, they're saying with reasonable quality. Okay. How is this differing from the command we're using? Maybe this is what we want to use instead. Oh, it's doing like fancy stuff with the palettes. Maybe it's this stuff here. Okay, we could actually maybe Change the rate. I feel like higher frame rate is always better than, like higher frame rate, lower resolution is like always better than the opposite. Like, yeah, we want to overwrite this. Get rid of this now. Like, there's a reason that I spent a fair bit of money and an entire day to play Bloodborne in 60 FPS. I did not care at all that it was 720. The higher frame rate was all I cared about. And I got it. So this hasn't really changed the file size at all. Okay, let's call this like Pluto 10. And then if we change the frame rate to 15, oh, the frame rate was already 15. Okay, now if we change the frame rate to 10, okay, it's what, like 25% less. I think in this case it's justified since there's no like motion happening, it's just changing colors. It doesn't, yeah, it doesn't, there's no need for that to be that. We could even go lower. So what if we dropped it, can we even drop it down to 5? Or maybe that's really nasty. But if it's 5, it's like it will be obvious from the GIF what's going on anyway. One of the rare cases where yeah, I think this is better. Okay, now it's like an acceptable-ish file size. So we'll use Pluto 5 in the GIF readmes. Let's copy it. And rename this to what, dwarf planet. Okay. But these other ones, the looping fractal, we need to change that. So similarly, let's try fractal. What does this look like by the screen capture? It's like super pixely anyway, whatever. We can try this at 15 and fractal 15.gif. Okay, yeah, it's 2 megs, not okay. Let's move it down to 10. Still too big. Again, this is like 25% loss. I feel like having this one at 5 is not going to, there's a certain amount of smoothness we need. But we'll just give it a go. Yeah, no, that looks like crap. No way. No way. I kind of wish there was more than one thing to pin to the top, but I understand and respect the decision that you can only choose one. Oh, good. I can select one for files and then one for that is all I want. Great. Okay, so we want this to be frame rate of 10 at least. How are we going to reduce the size down to half a meg? We could try this. How are we going to do this? Macro, delete, backspace, down here. Oh. Something happened. Well, I think I was being silly. Macro, forward, back. Yeah, what happens in that one? Oh, it's because of Emacs. Okay, so now if we make this to be the fractal.mp4 and we output that as fractal like tilde 10. What has this done? Where's the tilde? It didn't even run it. Okay. Did FFmpeg fail? Incompatible format. Okay, yeah. Oh no, it did. Oh, okay. Okay, that looks like total crap. But it is under the limit. Let's change the size of it. Okay, they said 320 by 340, so let's change it to 300 by 300. Yeah. Okay, like, yeah, this looks like crap, but it is under the limit. What does it look like compared to this version? I mean, sure, there's like ugly dots and stuff everywhere, but it's like, maybe, I mean, I think we have to go with it. It's, the file size is only going to get larger, and it's under the limit. So I think we just need to go with it. What's not okay is like opening the README page and then like you just see like stuff loading because of internet download speeds. Looping factor. And then finally we want to do the rainbow triangle example as well. Let's replace all instances here of fractal with rainbow triangle. And try this example. No. Even larger as a GIF, not okay. Let's move it down to 50, 10. How is it even larger? Maybe we just want the details. And we only care about the file size. This is still really large. I wonder if this would be okay at 5. Like it's clear these things are GIFs. We'll give it a go. Probably with this, it would just be. It would be too bad to let it go to 5, but we'll see. Okay, it's like within the limit. No, that's not acceptable. Like this is what like the I have certainly seen some web games made in Unity that look like this. Not intentionally. So we'll do this, but we're gonna have to simplify it. So yeah, this is the tilde version. Okay, the tilde version has come up to the limit. Yeah, it looks like total crap. Doesn't even look like a. Wait, how is the width of it changed? Oh right, it's because it's like squishing it. Can I just say like S is 300? No. Okay, so it looks like it's, by default it's 512 by 588. 512 by 588. Overwrite this. So we want the. No, it's still really large. It looks more crap and is even larger than this one. What to do? I could argue that this rainbow triangle example is more important than the others. On the other hand, there's nothing really visually sophisticated happening, so we could even reduce the frame rate. Reduce the scale. So say we change it, let's call this like 15, 150. How large are these? Okay, so like 3 squared is 9, 2 squared is 4, 4 is half of 9. So if we actually change this to just be like 200 by 200, it might halve. It might get us down to an acceptable version, even at 15 frames a second. Okay, so this is unnecessarily smooth and 1 meg. Yeah, let's change it to 10. Okay, this is within the limit. It's fine. This is what it's going to be. Also, we should save like the command that we've been using here. Oh, where's this currently saved? Someplace we don't want. So let's save this as videos, WASM, GIF converts, ffmpeg, commands.txt. Okay, great, it's there. Oh, this like file pilot is just so superior to any other file explorer. Like it's, yeah, you're just like, this is a text file, I want to know what's in it. Spacebar, there it is. It even plays GIFs as well. It even plays the stuff we made. Oh, I spoke too soon. It doesn't. Well, at least shows us the first frame. It's better than nothing. Okay. So now we've got these GIFs of an appropriate size in here. We can now move on to the README stuff. Let's get out of here. Git status. Oh, we can get rid of this blah. But otherwise, what do we... Okay, let's add all the GIFs separately. Replaced GIFs with better sizes, added dwarf, planet GIF. Okay. Now, yeah, for the shader stuff, tidied up. Yeah, Pluto example. Okay, so now we can edit the README. It's taken us a while, but let's just clear everything. Run Emacs read. Okay, compile the project. Simply run dwarf planet or replace rainbow triangle with dwarf planet. Okay, and then Pluto, yeah, the New Horizons photo of we can't help ourselves at this stage. Does the number of Pluto go, okay, it does go before it, of 134340 Pluto changes between color and black and white. Well, it's more like grayscale and grayscale. And then here, a browser window displays a photo of Pluto that changes between color and grayscale. Okay. Diff, change those things. Anything else in the README to add? I don't think so. Yeah, git push. Oh well. Added dwarf planet example to README. Okay. Okay, and then I think we are done for the day. We now let's just check it. So now in our WASM examples. Okay, stuff is still like popping in, not great, but it loaded very quickly. Well, that's not true. It loaded quicker than before. I kind of want to change the sizes of these to all be consistent. Presumably we can easily do this. How do we do this? Okay, GitHub Markdown, change the size. I think we had to do this in the Butterfly app, and we think we looked this up online, and that it wasn't obvious how to do it anywhere, and then we just guessed based on HTML markup, and it worked. So we'll do that. Let's just look at what we did in the Butterfly app. Where's the README? I mean the source code for it. Hello. Oh no, we didn't. Maybe we will need to look at this stuff. What about the README for the for this? I guess we also didn't specify it. Okay, we will need to look this up. Yes, yeah, README GitHub images change size. We might, since this is really tedious and complete trivia, we might use some LLM time to get this. But Huggy kind of gave it to us. All of these tried and failed. So we can use like HTML in GitHub instead. Oh, hopefully we can use like relative sizes. Let's try this one. So we want to adjust the rainbow triangle. Okay, so say we yeah, so say we say this sort of icon.jpg, and then we just make the width 300, and then we don't specify the height. Oh wait, what's the markdown comment syntax? What's the comment? Is there no comment? Ridiculous. Okay, let's save this as 2. Let's just give this a go. Test with the GitHub image sizes. Let's see if this works. Okay, it did. Crappy and blurry, no one cares. They can see it's a rainbow triangle that's rotating. Okay. I'm still a bit annoyed that the comment, like the comments in case the image we load are not showing. This is more like HTML trivia. How do we do that? Adding comments to HTML images. Like, is this like hover? Is this like a hover over comment? Yeah. HTML image hover over comments. What even? It's just the title attribute. Is that it? Breakthrough JavaScript. Yeah, okay, we're just gonna try title. So it was just like, this is stuff no one should memorize. It just wasted brain space. What is it? Okay, so like, wrap the, no. Yeah, I think it would just be title equals blah. Okay, that's all we need to do, apparently. Okay, So so we want to try the title equals this. Okay. GitHub readme. Okay, that does the same thing by the looks of it. Okay, so let's make all of these consistent then. Don't need any of that anymore. Goodbye markdown syntax. Would it be nice to have like some other argument to specify the size of it as well? So yeah, so we want to now replace everything here, rainbow, triangle, with dwarf. All of these are like 300 by 300 anyway, but we should make it clear in the code what's happening. Oh, that's literally all I'm changing. Okay. Okay, and then so yeah, this can go. That we just tested. This one, that's the message we want, and wait, there's only one place that this is changing. Looping fractal. And then this one up here. Okay, but this should be blinking screen. Okay. Blinking screen example, looping fractal, rainbow triangle, dwarf planet. Pluto, rainbow triangle, Julius sets rectangle. Okay. And all of these are now 300. Git commit made sizes of gifs in readme consistent. Okay. Let's check this out now. Hurrah. Okay. I wonder if we should link New Horizons photo. I feel like we should. get rid of some of this. Yeah, get rid of that. Get rid of that. So old version. That up. New version. So we want to go to the dwarf planet exam. Oh, there's some other stuff to clean up as well. There's no need for this RRBQI file anymore. Git remove RBQI. We could probably just clean up the random files from the entire project as well. Yeah. Okay. Oh, we should also change the license stuff to never ending list of admin stuff. It was okay. We began the day with like figuring out the fun, the fun method, the grayscale change, and now it's like onto the tedious housekeeping. But first of all, like the markdown. Cheat sheet. Why? So I need to stop using the inferior search and the proper one. So, markdown cheat sheet. So yeah, the URL. How do we do that? Hyperlink. Square brackets around the name and then round brackets around the link. So when we say the New Horizons photo of 134340 Pluto, here's where we want to put the URL. It is this one, correct? Yeah. Okay. Let's try again. Yeah, great, linked, and okay, what else now? We want to do the license thing. Let us get that working. So how long have we been streaming for? 2 hours, half an hour. So yeah, license stuff. So I think we can just like delete the old license. Like yeah, we've already, by including the package as a dependency, it's now, the license is already in here. So, and we've already said at the top of the README that there's a typo. Actually, it would be good just to put this entire thing through like a spell checker as well. But yeah, we can just do git remove license old. And then, let's see, the Sublime text spell checker catches many things. Somewhat decent. So now we do document, where is it? Oh, it doesn't like grayscale. That's fine. Add. Okay. More clean up. Okay, so now there's no like weird MIT unknown license. It's just cleaned up. Yeah. I wonder if we should have like another header here that's like examples. Maybe I'm overthinking it. Perhaps this is fine as it is. All right. Yeah. I guess what now? So Zig 14 has been released, which is super cool. Well, again, I think the first thing to note is that we've now get off this. Now that we've made all of these examples, we can port the sliding puzzle game. We know how to make the make the window. How to make WebGL is extremely fussy, and we figured out how to navigate around its fussinesses in order to draw fragment shaders. Well, in order to pass arguments, pass binary data from within the WASM to WebGL, how to structure the fragment shader so that it doesn't have hiccups when it's doing that, and then finally get a texture. So we've done all of the components necessary for our sliding puzzle game. It would be good to, so Z14 has been released, it would be good to port, well, yeah, the sliding puzzle game is built with like some weird version of Zig. Some like, it's not weird, just like a dev build. It would be good to make it concrete, version 14. As Andrew Kelly said in his like talk, building software from source, you should always use official releases of software when you're building stuff. And yet almost everyone seems to post some examples of Zig projects which need like compiler version, like dev 1080 point blah blah blah, which I have done in the past, but only because it's dependencies in which other people are doing that. So let's see if we can build the sliding puzzle example in 14 now instead of dev blah 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 version. This so we have a couple of dependencies. We have ZOpenGL. Will the build system be okay? Let's check it out. Hasn't yet been updated. It may not work. Let's give it a go. I should look into like downloading Zig and like that tool that allows it to be downloaded from like the non-noob way. Oh, it looks like is the Zig website currently flooded? Oh no, people are doing it. Zig download mirrors. Okay, so say we tried copying it from this version. So what is it? We replaced ziglang.org with Linus dev. Ziglang.org builds. Okay. Just what's that downloads here? No, it's 6 hours. No way. We'll do it the usual way. One hour, 34 minutes left. Okay, I guess that's the end of the stream then. So next time we will investigate. next time, yeah, we will start porting our projects to Zig 14. Yeah, especially when we're downloading 11 kilobytes a second. Everyone must be downloading Zig right now. Oh, anything else we could do? Like, yeah, we did, yeah, I've done what I wanted to do today. A lot of changes this time around. Yeah, the changes to the build system are gonna affect us for sure. Oh, we can see if raylib, if the build file here has been updated. Maybe not. Oh yeah, this is gonna have to change, I think. Probably. Well, we can see we already have some versions of the Zig compiler installed. Yeah, what do we have? So if we go Zig current version, so we have some dev version of this. Let's say we go to our, not our sliding puzzle, but like the butterfly quiz app. If we now try and build it with Zig current, will it do it? No, raylib's file is failing. It's wanting like define C macro, and that's presumably still in here. Define C. Oh no, it has. Oh, it has been updated. Oh, okay, that's really good. Why? Given we like updated this really recently, why is this failing? It's failing on 170. Okay, oh, maybe, oh, I think we used like the official 5.5 version, and okay, this was updated after this 5.5 version. Okay, we're gonna have to replace the raylib dependency in these projects yet again, but this time with like the better Zig file. Well, maybe we can just swap out the build.zig file. Yeah, that doesn't feel correct. We'll do this next time. We have yet more maintenance to do, but yeah, we've taken a huge stride towards porting our sliding puzzle game. So and helping other people to do it as well. To be able to port their games made in Zig to the web without using Inscription, without using Socal, without using Vigili and other things. It's just making a simple WASM that contains it all. So also, I want to know how large these resorting WASMs are. So say we go to Zig WASM examples. Let's just like clear the cache again. So let's say Zig build. Let's just build everything. Blinking screen de-optimize equals release build. And then we'll get this. Keep these up here as we do that. Yeah, release build is meant to be release fast. It's rainbow triangle. Am I spelling stuff incorrectly? Looping fractal. Isn't it nice when it just builds this quickly? Like done. That's it. Okay. So okay, so understandably the rainbow triangle and the rainbow fractal are really small. Why is this blinking screen 516 kilobytes? Yeah, what? Why is the WASM that large? It's not doing anything compared to these previous ones. Okay, so yeah, the rainbow triangle WASM is what? 28 kilobytes, okay. 27 kilobytes. Understandably, memory has been assigned, so this is like half. This is a meg. But then, yeah, what's happening with this blinking screen example? That doesn't make sense to me. Like what? Maybe this is something to invest. We might investigate this next time. Really bizarre. It's like it's not doing anything. In what world does this get compiled to something this large? Like, is this an error with FilePilot? No, it's apparently really large. What? Yeah, really confused. Is it something in the build script? Everything's basically the same, so it shouldn't be. Yeah, this is so bizarre. Anyway, lots of stuff to do next time, but it is within reach. Porting our puzzle game is within reach. Soon we will be able to see. Soon this will be on itch. So very soon. But yeah, thanks to everyone who came by, and yeah, see everyone later. Bye.